Good morning, everyone. Now, the next topic of the lesson, organic chemistry, is nomenclature. We have already discussed about the nomenclature of alkane. Now, today's our topic is nomenclature of cyclic hydrocarbon. But before starting the new topic, let us discuss something about COVID-19. Actually, there are certain guidelines for the COVID-19. The first one is wear mask properly. The second one is wash your hand regularly for 20 seconds, at least for 20 seconds, with the help of soap and water. And the main important thing is maintain the social and physical distancing. Do not share eatables and water bottles with anybody else. Now come to the topic, that is nomenclature of cyclic hydrocarbon. We have already discussed about the nomenclature of saturated hydrocarbon. It means alkanes. Now here the topic is nomenclature of cyclic hydrocarbon. The term cyclic means in the form of a ring. Those compounds which are in the form of a ring. So to write the name of the cyclic compound, for that there are certain rules. The first rule is, that is prefix. And prefix is cyclo. So for to naming the cyclic hydrocarbon, we have used the prefix cyclo. So the prefix cyclo is added to the name of the corresponding straight chain alkanes, and if the hydrocarbon is unsubstituted. Now the meaning of the unsubstituted is, that is unsubstituted. So the meaning of unsubstituted is, it is unbranched. Unbranched. The meaning of unsubstituted is unbranched. So for example, this is a cyclic hydrocarbon. This is a cyclic hydrocarbon, and now this position is, in these position there is carbon atom. So here 1 carbon atom, 2 carbon atom, 3 carbon atom, 4 carbon atom, and 5 carbon atom. So 5 means pentane. All are, there is no double bond. So they are the, this one is the pentane. Now for to name the cyclic hydrocarbon, we use the prefix cyclo. So its name is, first of all, it is cyclo. And how many carbon atom are here? 1, 2, 3, 4, 5. So 5 carbon atom are here, and all are connected with a single bond. No double bond, or now no double bond is seen here. So it is pentane. So its name is cyclopentane. Its name is cyclopentane. The term cyclo represents the cyclic structure because it is in the form of a ring. It is in the form of a cycle. So its name is cyclopentane. Okay. Now the second rule. According to the second rule, if the cyclic hydrocarbon is substituted, if the, that is, it contain branches. If the cyclic hydrocarbon is substituted, it means it has the branches. So for that, for such type of a hydrocarbon, there are certain rules for such type of a hydrocarbon in which the branching is present. The first one is under this heading. The first rule is number the chain in such a manner number the chain in such a manner that lower number is given to the group that comes first in alphabetical order. So this is the first rule. Number the chain in such a way that lower number is given to the group that comes first in the alphabetical order. Now the example is, for example, we have this one structure. How many carbon atom are there? 1, 2, 3, 4, 5, 6. It all are connected with a single bond. It means it is a hexane, and it is a cyclic structure, so we use the term cyclo. So it is a cyclohexane. For example, we have a cyclohexane and there is a branching. The one branching is here and the another branching is here. So these are the branching. Now again, this position shows it contain carbon atom. Here the carbon atom is present. Again here the carbon atom is present. All the point shows they contain the carbon atom. 1 carbon atom, 2 carbon atom, 3 carbon atom are present in this side chain, and only 1 carbon atom is present in this side chain. So for example, we have a such type of a structure. So now our aim is to name such type of a cyclic hydrocarbon. So first of all, give the numbering should be done for such type of a carbon, that is a hydrocarbon. So 1, 2, 3. This is first position. This carbon atom get 1 position. This one get 2 position and this one get 3 position. Now according to the rule, this is the rule. Number the chain, this chain we are talking about, this chain. Number the chain in such a manner that lower number is given to the group. That lower number, this is the keyword. This one is the keyword. That lower number is given to the group that comes first in alphabetical order. Now this one is, here only 1 carbon atom is present, and we know that the side chain is always of alkyl group. The side chain is always of alkyl group. So here only 1 carbon atom is present. So according to the alkyl group system, its name is methyl. Its name is methyl. And here how many carbon atom are present? Here 3 carbon atom are present. 1, 2, 3. And this is also a side chain. It is of alkyl group. Side chain is always belongs to the alkyl group family. And here 3 carbon atom are present. So 1, 2, 3. For 3 is prop. And the name is prop plus YL. YL from alkyl group. The YL from alkyl group. So prop plus YL is equal to propyl. Prop plus YL is equals to propyl. So this is the methyl. This side chain is of methyl. This is the methyl and this one is the propyl. So first one is the methyl and this one, second one is the propyl. So in the alphabetical order, the M comes first in comparison to the P, because ABCD in alphabetical order, M comes first in comparison to the P. So numbering is done in such a way that the number which comes first in the alphabetical order, it gets lowest possible number. That's why we have done numbering from here. This is the reason why we have done numbering from here. So its name is, the name of the compound is, first of all mention the position of the alkyl group. The position of the alkyl group means mention the number of that carbon atom in which the alkyl group is present. Now that carbon atom where the alkyl group is attached, this one is the one carbon atom. So that is 1. This one is 1 methyl. This one is 1 methyl. Put the dash. This is the rule. After the number we have to put the dash. 3 again dash propyl, because its number is 3 and the base parent word root is cyclohexane. So the name of such organic compound is 1-methyl 3-propyl cyclohexane. 1-methyl 3-propyl cyclohexane. Now this is a rule that after the position, after the number, we have to put dash, then the name of the alkyl group, then this one is the methyl. Again we have to put dash, then again the position of the this one alkyl group, that is 3, dash, name is propyl, and what is the word root? The parent chain is cyclohexane. So it is 1-methyl 3-propyl cyclohexane. Now the next rule is for the side chain is if the side chain have more number of carbon atoms, then that present in the ring, then the ring or the cycle is treated as substituent. At that time, if the condition is that more number of carbon atom than that present in the ring, then the ring is treated as substituent. At that time the ring is treated as substituent. Now let us take an example. For example, we have such type of a structure. Now how many carbon atom are here? 1, 2, 3. So 3 carbon atom, it means propane. 3 carbon atoms stand for the propane, and this is the cyclic structure. So this one is the cyclopropane. This is the structure for the cyclopropane. If the condition is like this and we have such type of a side chain, now the side chain contain 1 carbon atom, 2 carbon atom, 3 carbon atom and 4 carbon atom. Now come to the rule, more number of carbon atom is present than that present in the ring. In this ring only 3 carbon atom are present, but in the side chain how many carbon atom are there? 1, 2, 3, 4. So if the condition is like this, so at that time where the more number of carbon atom are present, it is termed as a parent chain or parent hydrocarbon. Where the more number of carbon atom are present, it is termed as a parent chain, and that time this one is termed as a side chain, or it is termed as a substituent. Now if you name such type of a compound, so from which carbon atom chain is attached, cyclic structure is attached? So this is the one carbon atom. So from 1 carbon atom the cyclic chain is attached. So it's at that time its name is, the name of the side chain is kept in a bracket, that is 1 dash. What is the name of this? This is cyclopropane. The name is cyclopropane. This one is not propane, that is cyclopropyl, because it is a side chain. Now it is a side chain, so its name is cyclopropyl. And the parent chain is 1, 2, 3, 4, and this is 4 means but, that is but. And here all the carbon atom are connected with a single bond, so we use the suffix ane. So its name is butane. So the name is 1 cyclopropyl butane. 1 cyclopropyl butane. Its name is 1 cyclopropyl butane. So this is the special kind of a nomenclature for the cyclic hydrocarbon. And this is the type of a nomenclature when the substituent or the side chain is branched. If the side chain is branched, so we have to follow such a rules to name the cyclic hydrocarbon. So now the next is let us take the new topic, that is IUPAC. That is, the next topic is IUPAC nomenclature. IUPAC nomenclature of organic compounds having functional group. IUPAC nomenclature for the compound having functional group. Now before starting the IUPAC nomenclature of organic compound having the functional group, now let us discuss about the functional group. What are the functional group? And how we can, what is the suffix or the prefix used for the functional group? So the first functional group is carboxylic, that is carboxylic acid. So carboxylic acid is a functional group. For that we have used COOH. COOH is used for the carboxylic acid, and for that the suffix used is oic acid. Oic acid is the suffix for the carboxylic acid. Now if the functional group is amines, if the functional group is amine, so we can recognize the amines as NH2 or it is NH or it is N. So these are the symbols for the amines, and for that the suffix uses amine. For that the suffix used is amine. Now if the third one is the alcohol. If the alcohol is present as a functional group, so for that this is the functional group. This is the functional group OH. If the OH is present, it means it belongs to the alcohol family, and for that the suffix is ol. Butanol, propanol, pentanol. So this is the ol. Now the fourth one is ketones. Ketones. If the ketone is present as a functional group, so for that C double bond O, or sometime it is written as only CO. No double bond is displayed over here. So for that the suffix is on. This is not one. This is not pronunciate as a one. This is pronunciate as a on. That is ketone, propanone, pentanone, butanone. This is the term. And if the functional group is ether, if the ethers are present as a functional group, so for that the presence of the ether is shown by ROR. ROR. Now R is the alkyl group. These two R represent the alkyl group, and the oxygen linkage is present in between two alkyl group, and the functional group is ether, and for ether no suffix is used. No suffix. For ether no suffix is used. We have used prefix for the ether, and that is known as alkoxy. That is called the alkoxy. For ether, ROR, no suffix is used. Only we have to use the prefix, and that prefix is known as the alkoxy. That prefix is called the alkoxy. So these are the major, and the one more is this is one more another this one is ester. If the ester is the functional group, so for ester the symbol is COOR. COOR is the symbol for the ester, and for that the suffix is OAT, ethanoate, propanoate, butanoate. This is the suffix which we use for the ether. So these are the major functional group, and one more functional group is that is called the halides. Halides means halogen. If we are talking about the halides, it means we are talking about the halogen. It is represented by X, and here the meaning of the X is fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine and iodine. So these are the halogens, and these are termed as the halides. And for the halogens we don't have any suffix. No suffix is present for the halogen. Only we use the prefix. And that prefix is known as halo. That prefix is known as halo for the halides. Halo, that is halo term is used for the halides. So these are the major functional group, and rest alkane, alkene, alkyne, you all are aware of the alkane, and alkyne. When the carbon single bond is present, it is called the alkane, and for that ane is the suffix. When the carbon is connected with other carbon, it is called, when the double bond is present, it is called alkene, and for that ene suffix is used. When the carbon triple bond is present, that is called alkyne, and for that ine, ene, ine. So these are the suffix. These are the suffix which we used in case of the saturated hydrocarbon, and these two are the unsaturated hydrocarbon. Okay, now come to the nomenclature. Again, the nomenclature of the organic compound having functional group means when we have such type of organic compound or such hydrocarbon in which the functional group is present, so how we can write the name or such a compound? Functional group is present, or we can say that if the double bond is present, because earlier we have already discussed about the alkane, means we have only discussed about the carbon single bond. But what happened when the carbon double bond is present? So definitely there is a slight change. So in such a case, for example, the compound having one functional group are called if the one functional group is present. If we have only one functional group, if one functional group is present, so one means mono, so it is termed as a mono functional. Such a compound is termed as a mono functional compound. And if two functional group are called, it is called a difunctional. And if many functional group are present, so we have to use the term polyfunctional. We use the term polyfunctional compounds. This is the monofunctional compound, and this one is the polyfunctional compound. So to write the name of a such compound, we have to follow certain rule. The first rule is, first of all, the rule is same: choose the longest chain. Choose the longest chain that contains contains functional group. First of all, our first task is to choose the longest chain that contain the functional group or that contain the double bond, that contain the functional group or that contain the double bond. And the second rule is number the chain in such a way that functional group gets the lowest possible number. The functional group gets the lowest possible number means the carbon atom where the functional group is attached, that carbon atom should get the lowest possible number. This is the meaning of this statement. And the third one is write the suffix. Write the suffix of the functional group. These are the suffix. We have already discussed about the suffix. Write the suffix of the functional group after the name of parent chain. Parent chain. After the name of parent chain. For example, butane. If the butane is the parent chain and alcohol is the functional group. If the butane is the parent chain plus alcohol is the functional group. Butane is the parent chain and alcohol is the functional group. So its name is butanol. Its name is butanol. So suffix of the functional group. Write the suffix of the functional group after the name of the parent chain.